let's work a real simple example problem with two resistors in series. So let's say we have a 12-volt battery, which is like a car battery, is like 12 volts. And it's going to push current through a 2-ohm resistor and a 3-ohm resistor in series, because there's only one conducting path through these two resistors, so they are in series. And what do we want to find? I want to know, what is the total resistance of the circuit? What's the total current? And what is the current through I1 and I2? Kind of a trivial question there. And then what is the voltage drop across this resistor, and what's the voltage drop across that resistor? So if you're watching this at home or in class or whatever, pause the video now and try to do it yourself. All right, let's solve it. So the total resistance for resistors in series, if they go, okay, there's only one conducting path through these two resistors, so they are in series. They have the same current, which makes this kind of trivial. So you're just going to add up the resistors. And so my answer is 5 ohms. Simple. Now, the ones in parallel a little harder. We're going to do that one here in a little bit. Now for part B. Well, really what I've done in my imagination is I have taken these two and I have combined them into one resistor. Now obviously you wouldn't need to do this. This is really a simple problem, but we're going to do more complicated problems. So one of the things you could do is redraw the circuit. So I'm going to redraw just a quick little sketch. And this is 12 volts, but now this is 5 ohms. And this is the total resistance of the circuit, and this is the total voltage of the circuit. So the total voltage equals, well, this is Ohm's law, right? So I can solve it for the current. And so the total voltage was given to be 12 volts, 12 joules of energy per coulomb of charge delivered to the circuit by the battery. And then the resistor says, hey, 5 ohms. You want to go through me? You got to give me 5, sorry. You got to give me 5 volts to get 1 amp to flow through it. That's what an ohm is. An ohm is a volt per amp. 5 volts needed to get 1 amp to flow through it. Well, I've got more than 5 volts. What do I have? A 12 volts. So I'm going to have a lot more than 1 amp. Well, volt cancels volt. I'm left with 1 over 1 over amps, which is amps. What is 12 divided by 5? 2.4 amps. 2.4 coulombs per second going through that circuit. You all done? Huh? Okay, just hold on to it. All right, so that's the total current. Oh, and by the way, since the total current, this battery is putting out 2.4 coulombs per second of charge is flowing through it. It's all charging through this. It's all flowing through this. So it's all equal. Because that's what defines resistors in series. It's part C. Well, now I know what the current is and I know what the resistance is. It's easy. I just use Ohm's law. V1 equals I1 R1. Well, I know what I1 is. It's 2.4 amps. And R1 is given to be 2 ohms. And I like to put volts per amp instead of ohms. You can just put ohms there if you want. But it just helps me learn what an ohm is, and it also makes the units amps cancel. And I'm left with 4.8 volts. That's what V1 is. Now let's do V2. Well, that's equal to I2 R2. Well, what is I2? Well, it's 2.4 amps. They're in series. They have the same current. And then this is 3 ohms, which is a volt per amp. Now, what is 3? Well, 3 times 4 is 12. Carry the 1. 6, 7. So it's 7.2 volts. Now, does it make sense that it's 7.2 volts? Why does it make sense that it's 7.2 volts? Because when I jump, look, I got 12 volts up here, and then I gotta lose 4.8 volts, and then what do I have to do to get to 0? Well, what's 12 minus 4.8? 7.2. I gotta lose 7.2 volts to get to 0. Look, if I add these up, 8 and 2 is 10. Well, 5 and 7 are 12. It's 12 volts. They add up to be 12 volts. That's not a coincidence, folks. That's required. That's a way of checking your work. If you have resistors in series, when you add up their voltage drops, they better add up to the voltage you gave to those resistors in series. That makes sense to everybody? Okay. That is all for this example.